Yeah, today we are going to talk about a topic called as process synchronization. Okay, last class we have studied about threads. Okay, in thread concept we have studied about what is a thread, what is multi-threaded programming, and at the same time what is implicit threading. All those concepts we have studied in previous class. In this class, we are going to talk about what is a process synchronization, what is a critical section, see what are the various topics comes under critical section. All those topics we are going to study in this class. Okay. See, next one is this is second unit, second chapter. Okay. See what actually the process synchronization is. Generally, if we have two processes and one resources, those two processes is trying to access the same resource at a time, then there is a problem of process synchronization. Actually, process synchronization is nothing but it is one problem. See, problem is if there are two processes, only one common resource. Okay, those two processes is trying to access the one resource at a time. Okay, it means one resource can access one process at a time only. But here what happened? These two processes are trying to access the one resources at a time. Then we can call it as a process synchronization. Okay. See, the technical definition of process synchronization is the process synchronization is the task of coordinating the execution of processes in such a way that no two processes can have access to the same shared data, or we can say resources. It means that if those two processes can't access the one resource at a time, then there is no problem of process synchronization. See, when this process synchronization is came into existence means there are more number of processes there is only one common shared resource, then only there is a problem of process synchronization comes into existence. Okay, here it is specially needed in multi-process systems when multiple processes is running together and more than one process trying to access the same shared data resource, then only we come across the process synchronization problem. Okay, see, generally what happened, this two process is trying to access the same resource means there is a problem of inconsistency. So inconsistency means here when there is a problem of process synchronization, then it leads to the concept of inconsistency of shared data. It means inconsistency means at a time those two processes can't access the resource at a time. Okay, so the change made by one process not necessarily reflected when other process access the same shared data. It means at a time only one process can access the same shared resource or shared data. Okay, so this is the process synchronization. Okay, see, if you see this diagram how the process synchronization work means, here we have two processes there, process A and process B. Here we have one common memory, that is memory location. Okay, assume that this is process A, this is process B. Okay, here what will happen, what is process synchronization means, at a time here what is the work of process A? Process A is writing the data to the memory, at the same time process B is reading data into the memory. Okay, at a time only one process, either process A write the data or process B read the data. At a time only one process can do the operation. But what is meant by process synchronization means, at a time process A and process B trying to write the data and read the data into the memory, then there is a problem of process synchronization. See, here at a time process A write the data into the memory means there is no problem. At a time, at another time process B is read the data into the memory location means there is no problem of process synchronization. When the process synchronization occurs means at a time process A and B is trying to access the memory. That means process A is writing, at the same time process B is reading at a time. That means these two operations can be done simultaneously, then there is a problem of process synchronization. Okay, so next one is critical section problem. See, what is meant by critical section problem? What is meant by generally critical section is nothing but it is one area where we are going to execute where we are going to execute the process at a only one time. Okay, that means in this critical section area, only one process should be executed. If we have more than one process, that means if we have multiple processes there, then among those multiple processes in the critical section, we are going to execute only one process. Then that region we can call it as a critical section. Here, why can we call it as a critical section problem means we have multiple processes are there. We are running only one process in the region, critical section region. Then we can call it as a critical section problem. Here we can say a critical section is a code segment that access shared variable and has to be executed as an atomic action. That means critical section is a code segment where we are going to execute the process, one process at a time. Here atomic means only one process. Okay, it means that in a group of cooperating processes at a given point of time, only one process must be executing in the critical section. Okay, simply we can say critical section is a area where we are going to execute our processes in the area only at a time, only one. Okay, if any other processes also wants to execute in this critical section, then it must wait until the first one is finishes. Okay, you see, assume that we have two processes. Those two processes wants to execute those operations means definitely those two processes must be executed in the critical section area. Okay, at a time only one process should be executed in the critical section. Okay, after completion of the first process, then the second process should enter into the critical section. Okay, simply we can say critical section is a one area where the process is going to be executed. In the critical section, only one process at a time is going to be executed. Okay, here if you see the structure of the critical section, here we are going to represent this structure by using the do while. Okay, here entry section, next one is critical section, next one is exit section, next one is remainder section. See here, simply here we have critical section. See, in this critical section we are going to execute our processes. Here entry section means we can say it is just like as a entry to the critical section. Exit means after executing the process in the critical section, it will exit from the critical section. Okay, so this is the basic structure of the critical section. Okay, next here if you see the representation very clearly, here do is there, again while. We are going to represent this critical section by using the do while loop. Okay, entry section means it will controls the entry into critical section and get a lock on a required resource. That means once the process enters into the critical section, it will get locked. Okay, then next one is critical section. Critical section means where the process is going to be executed. So exit section is just like as a removing the lock. Why? Because after execution of the process, it will terminate. So for that one, we are going to use the exit section. Okay. This is the one more same representation in another form. Okay, so next one is what are the four essential elements of the critical section. Okay, so if you see the critical section just now representation, in that one we have majorly four sections. First one is entry section, second one is critical section, next one is exit, next one is remainder section. Okay, here what will happen is, see, entry section means it is a part of process which decide the entry of a particular process. Okay, it means it is just like as a entry to a particular process. Okay, it is just like as a entry to a particular process. For example, one process wants to enter into the critical section, it will done in the first phase, or it will done by using the entry section. Next one is the critical section. See, this part allows one process to enter and modify the shared variables. Okay, it is in critical section means just now we have said that critical section is the section where we are going to execute our process. While executing our process, it may shared some of the resources or variables. Okay, while executing, it may be shared or may not be shared. Okay, but when the process is going to be executed in the critical section only. Okay, next one is exit section. Okay, so exit section allows the other process that are waiting into the entry section to enter into the critical section, it also checks that a process that finishes its execution should be removed through this section. Okay, here what is meant by exit section means whenever the process is executed, whenever the process execution completed in the critical section, then it will comes to the exit section. Okay, if there is one more process is waiting for the execution, it will come to the entry section, then critical section, then only exit section. Okay, here next one is the remainder section. Okay, what is meant by remainder section? All parts of the code which is not critical and entry and exit section are known as remainder section. Okay, generally if you say, if you take one process, a process may contain some code. Okay, the code which are not present in the entry section or critical section or exit section, the remaining code what are available for a particular process is present in the remainder section. Okay, so these four are the essential elements of a critical section. Okay, next to here critical section, is there any solution to the critical section problem means if you found any solution to the critical section problem, that solution must satisfy majorly three requirements. Okay, see what we are saying, there is a problem of critical section. What is meant by critical section? If we have more than one processes at a time, only we are going to execute one in a critical section. But our task is not like that. We have multiple processes. Okay, our intention is those multiple processes is executed at a time in the critical section. But here what will happen is in the critical section only one process is going to be executed. So we can say it is a critical section problem. So how we are going to avoid those problem means, if you find out any solution to the critical section, those solution must satisfy the majorly three requirements. That is, first one is mutual exclusion. See what is meant by mutual exclusion. If a process is executing in its critical section, then no other process is allowed to execute in the critical section. Okay, here there are three processes there. Okay, so in the critical section only one process is going to be executed. Okay, so it is correct. Whereas if it is more than one process is executing in the critical section, so it is not correct. We can say it is a mutual exclusion. Okay, so mutual exclusion means if a process is executing in a critical section, then no other process is allowed to execute in the critical section. Okay, so next one is progress. So next one is bounded waiting. Okay, so first one is mutual exclusion, second one is progress, so next one is bounded waiting. See what is meant by progress? Progress is nothing but if no process is executing in the critical section, that means if there is no process in the critical section, other processes are waiting outside the critical section. There is no process in the critical section. There is one more process is waiting at the outside of the critical section, means before the entry section. Then only those processes that are not executing in the remainder section. Okay, we are going to give the chance to the processes, those processes that are having in the remainder section can participate in the critical section. Okay, so it is nothing but progress. Whereas what is meant by bounded waiting? Here bounded waiting means after a process make a request for getting into the critical. Generally there is a particular if we want to execute the process, there is a time limit. For example, if a process may have to execute for a 5 times or 6 times or 7 times, like that. If what happen in bounded waiting is after a process make a request for getting into the critical section, that means a process will a process may wants to execute in the critical section, there is a limit for how many other processes can get into the critical section. Okay, there is a limit, that means how many times though that particular process is executed already. Okay, that means if there is a chance for that particular process only, then the then this bounded waiting is allow the process executing in the critical section only. Okay, that means if a process wants to execute 5 times, there is a chance of executing 5 times. Okay, if 4 times is over, then it will give one more time. Okay, if 5 times is completed, then there is no chance for executing the particular process in the bounded region, that means in the critical section. So at that time there is no chance for the executing the particular process in the critical section. Okay, so these are three are the requirements. Okay, first one is mutual exclusion, second one is progress, next one, third one is bounded waiting. Okay, so next one is Peterson solution. See what is meant by Peterson solution. Okay, here generally it is a classical software based solution to the critical section problem. We can say it is one solution to the critical section problem. It is based on the software based solution. Okay, we can say it is a classical software based solution. Okay, generally Peterson solution, why we can call it as a Peterson means there is one scientist called as Peterson. Okay, Peterson solution is widely used solution to the critical section problem. This we can say it is a Peterson solution or Peterson's algorithm. This algorithm was developed by computer scientist called as Peterson's. So this name we can call it as a Peterson's. Okay. In Peterson solution we have commonly two variables, two shared variables. Okay. In this solution we are going to use two variables. That is, first one is Boolean flag I. Okay. Here we are going to use two variables. Okay. Flag and turn, turn. Okay, first one is Boolean flag I. It means initialize to false. Okay, flag I is always going to be, we are going to initialize false. Initially no one is interested, is entering into the critical section. Okay, see here, flag I always false. It means there is no process is ready to enter into the critical section. The next one is, next variable is shared variable intern. Okay, what is meant by intern? The process whose turn is to enter into the critical section. Okay, if you have, for example, if your process wants to enter into the critical section, then we are going to represent those variable as intern, turn. Okay, so if you see the representation, so here Peterson solution also preserve all these three conditions, that is mutual exclusion, progress and bounding waiting. Here what will happen, here just now we have said that here flag of I is false. Okay, that means here flag of I is false. No one is ready to enter into the critical section. Okay, see what is meant by turn? Turn is nothing but if a process enter into the critical section, then we are going to represent it as a turn. Here it means two variables, that is two processes are there. Flag I is one process, J is one process. Okay, for example, one process is trying to enter into the critical section, then we are going to represent those process using the variable called turn. Here flag I equal to true, turn equal to J means here the process J is trying to enter into the critical section. Okay, while flag I and turn equal to J, here turn equal to J means the process J is trying to enter into the critical section. Okay, so after it means here in the critical section the process J is executing. Okay, so again flag of I equal to false. It means in this critical section there is no process I. Okay, only the process J is executing. Okay, in this is the scenario where the process J is executing. Okay, if you want to execute the process I, then the code should be here turn equal to I, again flag of I and turn equal to I, here flag of J equal to false. Okay, whenever we change this while loop, flag of I and turn equal to J, automatically flag of I equal to flag of J equal to false. It means in the critical section there is one process, that is I process is executing. Okay, here in this is the scenario where the process J is executing. Okay, if you want to change this one as executing the process of I means just we are going to change as flag of J, in the I place we are going to use J, here turn equal to I. Okay, I turn equal to I, then while flag of I and turn equal to I. It means that whenever turn equal to I means the process I is going to be executed in the critical section. Okay, so this is the Peterson solution. Okay, see next one is synchronization hardware. See what is meant by synchronization hardware. Okay, so Peterson solution is the software based solution to the critical section problems. Generally sometimes the problems of critical section are also resolved by hardware. Okay, this is the hardware based solution to the critical section problem. Okay, just previously we have studied about the Peterson solution, that is a software based solution. So this is the hardware based solution. See, some operating system offers lock functionality when a process acquires the lock when enter into the critical section and release the lock after leaving. That means just like as a we are going to use lock mechanism. That means it is a, we can say it is a hardware based solution. Okay, after enter into the entry section, it will give one lock to the process. After completion of the execution, it will release the lock in the exit section. Okay, so when other process is trying to enter into the critical section, it will not able to enter in its as it is locked. Okay, once the process is executing in the critical section, it will get locked. Means when there is a one more process is trying to enter into the critical section, that means by using the entry section, it will not enter into the critical section. Why? Because here we are using the mechanism called lock. Okay, this is also one of the synchronization hardware. That means this is one of the solution to the critical section problem, hardware based solution to the critical section problem. Okay. Next one is mutex lock. See, what is meant by mutex lock? Here just now we have studied the synchronization problem for the Peterson solution. Here, synchronization hardware not simple method to implement for everyone to strict software method known as mutex lock. Just now we have talk about the lock mechanism. Those lock mechanism only we are going to represent by using this one. Okay, here do while loop, by using the do while loop. Here generally acquired lock means it is in the entry section. Release lock in a sense it is exit section. Okay, whenever the process is entered into the entry section and it acquires the lock, acquire the lock means it won't give another chance to the another process. Okay, after acquiring the lock, it will go to the critical section. After execution is completed in the critical section, then it is comes to the exit section. That means releasing in the exit section, lock was released by the exit section. Then after completion of the releasing of lock, then one more process is acquiring lock and enter into the critical section and release the lock. Okay, this is the mutex lock. This is the representation of the mutex lock. Okay, so next one is semaphore. See, what is a semaphore? Here semaphore is nothing but it is a one integer variable that are used to solve the critical section problem by using two atomic operations. Okay, here we are going to use two atomic operations. Those are wait and signal. Okay, so here the atomic operations are wait and signal. Okay, here semaphore is nothing but it is a one integer variable. Okay, we are going to represent semaphore as S, capital S. Okay, it is a variable that are used to solve the critical section problem.